Okay, we're going to continue on in chapter 8 with a new method of how to solve a quadratic. If you remember from the other lesson, there were 5 methods. There's the factoring method, which is the one we just spent 2 days on. There's the square root method, which we're going to do today. There's graphing. There's quadratic formula. And there's a method called completing the square. So these are all methods on how to solve a quadratic equation. A quadratic equation is some sort of equation that has x squared in it, okay? So we did factoring the past 2 days, and now we're going to do the square root method. So let me just show you a few examples of what this looks like. This is section 8.7. So an example might be 3x squared plus 4 equals 31. Okay? This is a quadratic equation. Factoring method would not work. So if you tried to do what we did the other day, which was take the, actually, you know what? Factoring method would work. I'm sorry. Bring the 31 over to the other side. You would get minus 27 equals 0. Take out a GCF of 3. Then take the x squared minus 9 and factor it. X plus 3, x minus 3 equals 0. And then solve each of these bubbles. You get x equals negative 3 and x equals positive 3. This 3 on the outside is just a GCF. It has no variable. It means nothing to us, right? So that was the factoring method. I'm going to do the same exact problem using the square root method, which is what today's lesson is on. So square root method is we're going to basically try to solve for x, get x by itself. The reason, here's the important thing, the reason you're allowed to do the square root method in this problem is because there's only an x squared in the equation with no x. Like there's no x in this problem, only an x squared. If there was an x in this problem, let's just say there was an x maybe on the 31, then you can't do the square root method. You can only do the square root method if it's only x squared and there's no x in the problem. You might want to rewind, hear me say that a few times, and star that and highlight that in your notebook. You can only do the square root method when there's just an x squared in the problem and there's no x, right? The x term is missing. So once you identify that you can do the square root method for this question, you want to get the x squared by itself. So imagine you were doing 3x plus 4 equals 31, right? How would you start to solve for x? You would subtract 4 from both sides, right? So that's what I'm going to do here too. So 3x squared equals 27, right? Then what would you do next to get x by itself? Divide by 3. So x squared equals 9, okay? Now, here's where the new skill comes in. When you have x squared equals a number, to get rid of that square, we need to get rid of that number 2. To get rid of that number 2, we're going to take the square root of both sides. As long as you take the square root of both sides, you're allowed to do it. When you take the square root of x squared, the square root and the square cancel each other out. And so this left side just becomes, I'm going to come over here, x equals. The right side, the square root of 9 is 3. But anytime you take the square root of both sides in pink like that, you're going to put a plus or minus on your answer. So there are 2 answers to this question, 3 and negative 3. We typically will write it as plus or minus 3, right? Notice we got the same 2 answers when we did the factoring method, right? And that is solving using square roots. Let me show you another one. Example number 2. Let's say you had 5, whoopsies. Let's say you had 5x squared minus 35 equals 0. You say, oh, there's no x term in this. There's just x squared. I can do square root method. So add the 35 over to the other side. Divide both sides by 5. Okay. Once you get the x squared all by itself, you're going to take the square root of both sides. The square root of x squared becomes x. As soon as you did square root, you add on a plus or minus. Now, the square root of 7 is not a perfect square. If you put the square root of 7 into your calculator, you get a decimal. 2.6457, blah, blah, blah. We're not going to write down decimals. We would leave our answer as the square root of 7. So the two answers for this question are square root of 7 and negative square root of 7. This problem was not factorable. So if I tried to do factoring method, I'll show you, I would have taken out a GCF of 5, and then I would be here, and then I would try to solve this by doing a double bubble, difference of two squares, but the problem is it's not a perfect square. 7's not a perfect square. So this is technically prime, and you wouldn't be able to factor it. Now, just because you can't factor it doesn't mean it can't be solved. It just means that it can't be solved using the factoring method, which is why we would have to use the square root method. Okay, let's try one more example. (6x squared minus 1 equals 71). Start by adding 1 to both sides. Divide both sides by 6. And you get x squared equals 12. At this point, you would want to take the square root of both sides. The square root of x squared becomes x equals plus or minus. The square root of 12 is not a perfect square, so I'm going to write square root of 12. And you're not going to leave your answer like this. The square root of 12 can be simplified, and that's where today's lesson comes in. In order to simplify a radical, there's a perfect square hiding in that radical, right? In the square root of 7 over here, there are no perfect squares. It's just 7 times 1, which is 7. But 12 has a perfect square in it. I'll explain this more on the next slide, but square root of 12 can be broken down into two radicals, 4 and 3, because you can choose any two numbers that multiply to make 12. I'm choosing 4 and 3. 4 is then a perfect square. The square root of 4 is 2, and the square root of 3 stays as the square root of 3. I bring down my plus or minus sign, I bring down everything else, and this is my final answer. X equals plus or minus 2 root 3. This skill that we just did right here is what we're going to practice today. So the lesson today is just on simplifying radicals. We're going to practice this skill so that we can come back and solve more equations. Okay, so let's start over again with our examples. I'm going to start at number 1 again. And I'm going to go through square root of 12 one more time. Now, you need to make sure you know your perfect squares to do this. You should know these off the top of your head. I would say up until at least 100, right? So the first perfect square is 1, because 1 squared is 1. The next perfect square is 4, because 2 squared is 4. 3 times 3, 9 is a perfect square. 4 times 4, 16 is a perfect square. 5 times 5, 25 is a perfect square. And we can keep doing this. Right? And I would say you should at least know up to 100 off the top of your head. And then if you needed to, like 11 times 11 is 121, right? You could keep going with the list if you needed to. So what I'm going to do is I'm going to break down the square root of 12 into two radicals. The two radicals can be any two numbers you want that multiply to make 12. Now, I would not choose 6 times 2. Even though 6 times 2 is 12, this does not help me in any way because square root of 6 is still a decimal. Square root of 2 is still a decimal. right? I haven't made any progress here on simplifying. So when you choose your two numbers, right, you want to choose two numbers that multiply to make 12, but one of those numbers should come from this perfect square list. Don't choose 12 and 1, because the square root of 1 is 1, and you just end up back where you started again. So never choose 1. So some people, when they make their list, they don't even include 1 on their list because it's kind of pointless. So two numbers that multiply to make 12, but one of them has to come from this list over here on the right-hand side, 4 and 3. So 4 times 3 is 12. Now I'm going to show the problem if you put 3 and 4, because it is the same thing, but I'll just show you how it's better to put the perfect square first. If you put the perfect square first, what is the square root of 4? The square root of 4 is 2. So it just becomes a regular 2. Radical is gone. I then bring down the square root of 3. And so that's my answer. Over here, the perfect square is the 4. So it would be square root of 3, and then this becomes a 2. Do you see how this could be confusing, right? It could be confusing because maybe by accident you write square root of 32, right? So we always put that coefficient out in front. So my suggestion to you is to always put the perfect square first, like I did on the left-hand side. All right, let's do another one. So square root of 32. I'm going to break it down into two radicals. I need two numbers that multiply to make 32, but one of those numbers has to come from this list of perfect squares. So you can pause the video and think. Hopefully you wrote 16 times 2, always putting that perfect square first. Very helpful. The square root of 16 is 4, and then square root of 2 stays the same. Okay? Now, don't take the square root of 4 and write 2 root 2 as another step. That's a common Susie mistake, right? The 4 doesn't have a radical sign on it, so you just stop, right? It's just a regular number. All right, try this one on your own. Pause the video, try to find the square root of 75. So hopefully you did 25 and 3. 25 is 5, root 3. Okay, all right, I'm going to change the screen. If you haven't written down your perfect squares, I would write those down on the side of your paper. All right, let's try square root of 48. All right, go ahead and pause the video and try it. Now, there are multiple ways to do this question. The easiest way is if you thought of the pair 16 times 3. 16 is a perfect square. 16 times 3 is 48. The square root of 16 is 4. So this is the final answer. Now, another person may have done the same question, gotten the same answer for root 3, but used different numbers. Okay? So here's what you could have maybe done. Maybe you thought 4 and 12. 4 is a perfect square. The square root of 4 is 2. And then you bring down your square root of 12. Here's the problem. Square root of 12 has a perfect square in it, right? So square root of 12 can still be simplified. We already did this example. 12 can become 4 root 3. Square root of 4 is a perfect square. That becomes 2. Bring down the root 3, and then this guy comes all the way down as well, and it's multiplication. So 2 times 2 is 4, square root of 3. Same answer as the first time, but so much more work. So how do you avoid having to do all that work? When you think of your two numbers that multiply to make the square root of 48, look for the largest perfect square that you can on that list. So starting off with 4, right, was not such a great idea. You should have started off with 16, and it avoids that mistake. All right, so I'm going to give you a few problems to try. Pause the video and then try them. So we're going to do square root of 50, square root of 180, square root of 98, and square root of 26. Pause the video and try these examples. All right, square root of 50 should be 25 and 2, becomes 5 root 2. Square root of 180, I did 36 and 5. That becomes 6 root 5. 98, I did 49 and 2, which becomes 7 root 2. And then square root of 26 was a trick question. There are no perfect squares hiding in root 26. So this answer would just stay as root 26 for your final answer. Okay, so this is the skill you're going to practice on the homework assignment. There are other methods on how to do this. One is called a factoring tree. The other one's called a upside down birthday cake or something like that. I don't teach them, but I am going to include on the assignment for you 2 videos that explain them. So if you like those methods better, you can do those methods and you should still get the same final answers that we are getting here. So you can choose your own method to do this. I think this is the fastest and easiest, but you need to know your multiplication tables and you need to know your perfect squares. So for people who are less familiar with their multiplication tables or perfect squares, you might like the other methods, even though they're more work, because the numbers are a little bit easier to work with. So if you want to watch those videos, give it a try, you can. All right, let me know if you have any questions, guys.